All right, welcome back. Yeah, we're good. Okay, welcome back to pre-calculus. We are going to continue talking about trigonometric identities. This should finish off our section 5.1, but we have plenty more where that came from. So let's go ahead and share the screen. Okay, and then here we are. We have show that cosecant squared of negative x times sine x over cotangent, is equal to secant squared. All right. So let's see what we're going to do with that. So like I said, we have to pick one side or the other side. All right. So we have cosecant squared x, negative x. Okay. Tangent of x, cotangent of x is equal to secant squared. All right. Now, for the most part, they're going to tell you, whatever we've got here. The usual side they want you to start on is the left-hand side. You can pick either, but notice how much stuff there is to do over here. And then, I've just got secant squared, so I'm like, where do I go? Okay, where do I go with this? So what we want to do is we want to say something clever and start with this side. All right. Now, once you've picked the side, okay, you're not allowed to pick the other side. Okay, you can't treat this like as an equivalency thing. You can't multiply both sides by cotangent and then leave that. You have to only work on the left-hand side. All right. So that's what I'm going to pick. So cosecant squared, this is tangent of x over sine squared of negative x, okay, cotangent x. Now you see the sine negative x here? What does sine squared mean? This is sine negative x squared. That's what sine squared negative x means. So we can use our odd even identities to say, well, sine of negative x is negative sine x times negative sine x, because I have two of them. Okay. Negative times negative is going to be positive. So we're going to have a sine squared x when we're done here. Okay. So this is going to be tangent of x sine squared x cotangent x. Okay. Now what's cotangent x, right? We know that tangent, right? Tangent of x is equal to 1 over cotangent of x, right? Or we could say something like cotangent x equals 1 over tangent x, all right? So it's the reciprocal function. Now you could look at that and say, oh, reciprocal, this is going to go upstairs when I turn it into a tangent, okay? Let's work a little bit slower. So we've got tangent of x, we've got sine squared of x times, this is going to be cosine x over sine x, right? So sine x times cosine over sine, this can cancel. Okay, so we're going to have tangent of x times 1 over sine times cosine. Okay, I'm just trying to spread it out so I can easily see what I'm looking at to see what's going to happen here. Okay, what's tangent? Tangent is sine x over cosine x times 1 over sine x times cosine x. So the sines can cancel, and I've got 1 over cosine x times 1 over cosine x, which is 1 over cosine squared x, which is secant squared x. And I think that's what we were looking for. It was. So that's how you solve an equation like that. Right? Now, navigating this, okay, like you guys are going to, honestly, doing it on paper is going to be a lot easier than doing it here. Okay. They only give you like so many choices to deal with. Okay. Whereas here you're allowed to use any of the algebra that you know. And they're going to make you go and do it into steps that are going to be kind of weird. Okay. So let's see here. So you could go backwards too. So let's see here. We are going to say something. So what's, oh, look at that. We have. So what did we do first? Okay, so now that I have it, I'm going to see if I can't take some shortcuts with it. So we're going to go cosecant squared x tangent x over, no, x. And this is going to be times, no. Boy, they are really picky. They don't like you to do this at all. Cosecant squared x tangent, no. Ah, come on, really? Okay, this was cotangent x times tangent x. Okay, it seems weird. I'm going to press Control plus. That will make it a little bit bigger. Okay, so you can see that. And select rule, I'm going to say odd and even. Okay, validate. Okay, it was. I wonder if it's going to have me check the answer here at the end. Okay, and then we're going to see, how about we look at cosecant squared x? Oh, I need a, oh, I'm going to need a fraction button here. So let's put this in our fraction. Actually, no, we're not going to need a fraction button. Let's do that, and then we'll say times tangent squared x. So as I'm running through this, part of me is thinking to myself, like, well, how can I shorten the number of steps now that I've done that, right? Because this is how I worked it out. But I only want to write so much in here. So let's validate that, say reciprocal rule. Okay. Now at this point, we have cosecant squared x times tangent squared x. And we know that cosecant, this is going to be sine squared x over cosine squared x times cosecant squared x. And we know that cosecant times sine is going to be 1. So let's go ahead and write this one. So we're going to have our cosecant squared x times, now we'll do a fraction. Let's make this bigger. Okay, sorry about that. Times, let's go with sine squared x over cosine squared x. All right. And which rule are we going to pick? We're going to pick quotient. I think we're going to pick a quotient. Yeah, let's pick quotient. Let's see if that's all right. I don't know. This is getting worse and worse because the number of steps is building up. The amount of time we've done is building up, and the check answer is going to be that much worse. So I'm kind of hoping it works out. Okay. And let's say this is 1 over cosine squared x. It's not going to like a lot of this. And we're going to say that's reciprocal. Okay, because cosine squared times sine squared is 1. Okay, we'll say validate. And then we'll say equals secant squared x. The rule again is reciprocal. Fingers crossed. Validate your proof. Oh, look at that. You said your proof is good. Check. It's not going to like it. No. Oh, it did like it. Okay, good. So yeah, I'd say that's really the trick here, is not to spend all your time like meandering through this with their way of doing it, or with the tools that they give you, but rather go through and do it on your own, and then go back and see, like, maybe I could make it more efficient. Okay, it's going to be bigger. Okay. All right, so this is 1 over secant a minus 1. Okay, 1 over secant a minus 1 minus 1 over secant a plus 1. And what do we say that this is equal to? We said this is equal to 2 cotangent squared alpha. 2 cotangent squared alpha, or A. All right. I would say the first thing I would want to do is get common denominators and add. Okay. So we're going to say this is secant alpha plus 1 over secant alpha plus 1, secant alpha minus 1 minus, and then we have secant alpha minus 1 over secant alpha plus 1, secant alpha minus 1. Okay. Secant alpha minus 1. Okay. This is at least the difference of two squares. Okay, so the first thing I'm going to do is I'm going to multiply these together, or add them together rather. We have secant plus 1 minus secant minus 1. So when I put this together, the secants are going to cancel, and we have 1 minus a negative 1. We're going to have 2. Okay, over secant alpha plus 1, secant alpha minus 1, right? Because we had common denominator, so we added the fraction. Okay, let's put this together because this looks like a difference of two squares here. So, okay, so this is 2. Secant times secant is secant squared alpha. The cross terms, right, the secant and the negative secant are going to cancel, and we get a minus 1. Okay, so far so good. All right, what's secant? Okay, secant is, right, so we have sine squared. See, I'm going to do my abbreviations here. Okay, divided by cosine. Okay, sine over cosine, that was tangent squared plus 1 is equal to secant squared. So if I move this over, right, this is going to be secant squared x minus 1 is equal to tangent squared x. Okay, so let's go ahead and say this is 2 over tangent squared x, and the whole minus 1. Secant squared minus 1 was tangent squared. And then 1 over tangent squared is going to be 2 cotangent squared x. And let's see if that, is that what we were looking for? Yeah, that's what we were looking for. Okay, so now I got to translate this and be a little bit more formal about it. Okay, and hope, goodness, I don't mess up a rule that they wanted to put in here. But yeah, let's just go ahead and say, okay, this is 2 over, okay, and I'm going to say, do I have parentheses? 2 over parentheses? I do. Okay, secant, I guess we'll say A, okay, minus 1 secant A plus 1, okay. You have to remember that they're only going to want you to do one row at a time, okay. So I think we could say this is going to be algebra. Okay, so this is going to be 2 over secant squared alpha minus 1. Okay, and again, I think our thing here is going to be algebra because we just multiplied that together. Okay, and then we're going to have 2 over tangent alpha, tangent squared alpha. We want to do a Pythagorean one. That's the identity we used. Okay, and then we're going to say 2 cotangent squared alpha, or A, and we used a reciprocal to do that. Validate. Your proof is complete. Very good. Okay, we can move on, I believe. Okay. By the way, this particular book, it will let you go around in a circle because you could perform correct steps like a lot of times, and it'll just keep letting you going until you've gotten some progress. So the fact of the matter of you could go through a lot of different pieces here, and it might take you a longer time to get the answer, and that's okay. But there are loops you can make in here that it's not gonna look like you're making progress. You aren't, but it's not, none of what you've done is wrong either. Okay. Okay, what do we have? We have the sine theta. Okay, so here we go. We have sine theta over cotangent theta plus cosecant theta. Okay. So what do we want to, oh, we have to show that this is equal to 1 minus cosine theta. Okay. So since we have a 1 minus cosine theta here, my temptation here is to kind of change everything into sines and cosine. What's my answer look like? It's got a cosine in it. So let's go ahead and try to do that. So we have sine theta over, what's cotangent? Cosine theta over sine theta plus 1 over sine theta. Okay. And now since we have our fraction, we can go through and say this is sine theta over cosine theta plus 1 all over sine theta. Okay. So we have sine theta over 1 divided by cosine theta plus 1 over sine theta. Yeah. All right. So go ahead and multiply. So sine theta divided by 1 times sine theta over cosine theta plus 1, which means we have sine squared theta 1 plus cosine theta. Okay. What's a fancy way to write sine squared? Well, you have to remember sine squared plus cosine squared is equal to 1. So cosine squared is equal to, no, sine squared is equal to 1 minus cosine squared. Okay, so we're going to say this is 1 minus cosine squared theta over 1 plus cosine theta, which is going to be 1 minus cosine theta, 1 plus cosine theta, divided by 1 plus cosine theta. Those cancel, and we end up with 1 minus cosine theta, and I believe that's what we were supposed to look for. Okay, so let's figure, do we want to make these exact steps when we're doing this? I don't really see it that bad, so, you know, I think we'll be okay. Okay, so let's go ahead and try this. So this is going to be, I wonder if we can skip this step and say this is sine theta divided by, okay. So let's go with sine theta divided by, what was our next step here? Was cosine plus 1 over sine theta. Okay. Aha. Cosine theta plus 1 over sine theta. Okay, and our rule is going to be that we did some algebra. Okay, validate. This line is incorrect, didn't like it. So I jumped too far, I did not like this at all. Okay, so let's go back. Okay, oops, I wanted to do divides by, oh no, not that, divides by. Jeez. Divides by, I still going to need a divides by in the bottom here, but I guess I went too fast, too far, I flew too close to the sun, they shot me down. So let's go with cosine over sine plus 1 over cosine. So this is going to be cosine, oops, theta plus, oops, over cosine theta. No, over sine theta, right? Yeah, over sine theta. Sine theta plus 1 over sine theta. Let's see if they'll accept that. It didn't like that either. Cosine over sine, 1 over sine. It did, it was okay. That is correct. We have to figure out how they want us to write it though. Okay. So it's kind of nice because like we have like a constraint that we have to make it to them, but at the same time we have a constraint that we have to conform to their way of doing it. What other things can we do? Why don't we do sine theta cotangent theta plus cosecant theta times cotangent theta minus cosecant theta, right? Multiply by the, right, the conjugate. You guys remember doing that in difference quotients with radicals. So let's see what we have here. We have sine theta cotangent theta minus cosecant theta divided by cotangent theta squared minus cosecant squared theta. Let's see if that gives us a better choice here. Okay. And no, I don't like this any more than you do. Okay. Oh, maybe that was the thing. Control Y. Control Z undo. Okay. And instead of algebra step, let's make it a reciprocal step. Okay. Nah, I still don't like it. Jerks. Okay. So I don't know what I'm going to do after this. So this was sine alpha parentheses, and then we have cotangent alpha minus cosecant theta and, all right, divided by cotangent squared theta minus cosecant squared theta. Okay, we're hoping for the best here. Let's make it so that we did an algebra step because we multiplied by the conjugate, and let's see if we like that. They did like that. Okay. Why did I pick that to choose to multiply by? Well, do you remember that we have a sine squared plus cosine squared equals 1? Okay, and if I divide everybody by sine squared, right, we get sine squared. We end up with 1 plus cotangent squared is equal to cosecant squared. What is, right, if we go ahead and do this, we could say that this is 1 equals cosecant squared minus cotangent squared. And then if I make this a -1, this is going to be cotangent squared minus cosecant squared. Okay, that's why I did this, because I knew that cotangent and cosecant, they're related. Okay, so I knew I could do something with this. I didn't know what yet, but I knew I could do something with it. So cotangent squared minus cosecant squared is equal to -1. Okay, so we are going to do a Pythagorean theorem thing there, so we're just going to pick this one. Okay, so we need fraction. Okay, and we're going to have sine theta parentheses cotangent theta minus cosecant theta, all divided by -1. Okay, and the rule that we're going to be dealing with here is we use the Pythagorean identity. Okay, we're okay. So let's see here. We are going to say this is going to be next possible, okay, is going to be sine theta times cotangent theta, okay, which is, I'll bet we have to do one step at a time, times cosine theta over sine theta minus sine theta times 1 over sine theta, because that's cosecant. Okay, so let's do this and say this is negative sine theta. Just moving the thing upstairs. Okay, the negative sign upstairs, and then we have cosine theta divided by sine theta. Okay, and then we have minus 1 over sine theta, because that's what cosecant was. Right, what do you want to call this? I think I'm going to call this reciprocals. All right, we'll check. This line is incorrect. Let's see. Let's move that. Take the whole thing and make it a fraction. -1. Oops. Oh, we wanted, no, we were okay. We wanted reciprocal. We're okay. This line is incorrect. All right, let's go back and just put in negative sine alpha times cotangent alpha minus cosecant alpha, and then see if that works. Oh, what is our thing? Our thing was an algebra step. Okay, God, you guys are picky. Okay, I'm going to be careful here. I'm just going to say, because I don't want to deal with the negative sign anymore, sine theta times cosecant theta minus cotangent theta. Okay, all I did was multiply the negative sign in. Okay, so notice the cotangent went negative. The negative times negative for the cosecant went to positive. And again, we used an algebra step. Fingers crossed that they're going to let me do it. Okay, they did. So now we're going to say this is going to be sine theta times parentheses 1 over sine theta. Okay. Minus cosine theta divided, oh, not that divides, cosine theta over sine theta. All right, and what rule did we use? We used a quotient reciprocal rule. That's what we used. We know it's not incorrect. We do. Okay. So I just want you to know like what's going on here. Let's create quotient, maybe. Let's complete your proof. All right, let's try it that way. Okay, so this is sine theta. Cosecant. I need to do it like the way I did it the first way. That's what I expect you guys to do for an identity. If you're looking at this, like I am never going to remember this. Like, first off, I am not sitting with you as you're doing your quiz. So if you're doing, steps that were not book approved here, I mean, as long as they work, all right, we'll be okay. But the one that I sketched out at the beginning, like that's fine. Okay, the one we sketched out secondly, that's fine. If you didn't put all these steps in here, that's fine. Okay, because you notice like I have a tough time with this too. So this is 1 minus. Okay. I'm just going to guess and say cosine theta. Okay, and we're going to say this is reciprocals. They don't like that. Let's see, 1 minus sine theta, come on, theta times parentheses cosine theta over sine theta. Okay. I'm going to run out of attempts here. I'm still going to say reciprocal. Nope, didn't like that. Maybe they didn't want me doing all of it here. Maybe I could just do cotangent theta. Okay, wow. 1, okay, minus sine theta. Okay, cotangent theta. Oh my goodness. Oh, please select a rule. What do we do? Do the reciprocal rule, you think, or algebraic rule? We're going to select that. We'll say algebra. Okay, then we're happy with that. 1 minus sine theta times cosine theta over sine theta. Okay, my rule is a quotient rule because we turned a cotangent into something. Oh my goodness. 1 minus, I'm going to say cosine theta, and the rule we used was algebra. Okay, sine, cancel sine. Yay, we're done. Okay. So, so the book can be, but like I said, as far as like showing you guys having to show stuff, this was about the best we were going to get. Okay, everything else shows you like 4 different things and said pick which one you like, but does not teach you how to do a an identity. So as terrible as this is, realize it was the best of a bad situation. Okay, so I think we've been long here. I got 3 done. Good Lord. I get so many more done if I just did it that way, but not happening. Okay, not happening at all. All right. Let's see. Let's sketch this one out. Okay. So this is going to be secant. No, secant squared. There's secant theta minus tangent theta squared is equal. Now, on this one, it actually doesn't really matter which one you start with because there's something you can do over here, like multiply by a reciprocal and see what happens. But they're going to pretty much force us to start on the left. Okay, it's not a bad rule, but you know, I usually like to give students a little bit more freedom. So let's square that out. That's going to be secant squared theta minus 2 secant theta tangent theta plus tangent squared theta. Okay. Now let's look at this and say, remember sine squared plus cosine squared equals 1. Divide everybody by cosine squared. So we have tangent squared plus 1 is equal to secant squared. Okay. So we have a tangent squared plus a secant squared. That's not going to quite do it. Okay. But let's see. Let's go with a tangent squared theta plus, let's put tangent squared theta plus 1 minus 2 secant theta tangent theta here, and this plus tangent squared. I don't like where that's going either. Yeah, I don't like where that's this is going to be kind of a pain. All right, that was a possibility. Okay, didn't go where I wanted it to go, but that's okay. Let's see here. Excuse me. Okay. I mean, I guess we could do something like this. We have 1 over cosine theta minus sine theta over cosine theta squared. Okay. So this would be 1 minus sine theta, right? Because they both have the same common denominator, over cosine squared theta squared. Oops. Not squared yet, just cosine. And this is going to be what? They're not going to like this. Right. All I did was hold the 2 out and then multiply the squared in. Okay, so just like we could do that, right? We have square root of 3 over 6 squared. We could say something like this is 3 over 6 squared. Okay, we could do that. So that's all I did here. And then we're going to have 1 minus sine theta, 1 minus sine theta over cosine squared, right? Sine squared plus cosine squared equals 1. So cosine squared equals 1 minus sine squared. So we have sine squared down here, 1 minus that. And then we could pull that apart. We could say this is 1 minus sine theta, 1 minus sine theta, all divided by 1 minus sine theta times 1 plus sine theta. And then some stuff cancels, and we end up with 1 minus sine theta over 1 plus sine theta. Okay, is that what we wanted? It is what we wanted. Now we have to figure out like what circuitous path we're going to take to get this to be the right proof. By the way, if this is what you end up writing down, that's fine, okay? Because a human is looking at your work for identities, whereas a computer is looking at your work for this one. If I do say so myself, humans are a little smarter than computers when it comes to this kind of stuff. Okay. So let's see. What did we want to do? This went, no, see, I tried this. I didn't like where it went. Okay, we could have probably forced the issue and gotten something out of it, but this wasn't going anywhere where I thought it was going to be like a productive use. Okay, so that's why I abandoned it and said, don't like where it's going. Let's try something else. Okay, so that happens. It's going to happen to you. It's okay. So let's go ahead and say this is going to be 1 over cosine theta, all right, minus sine theta. Oh, never mind. I'm going to need a different fraction. Okay, so this is sine theta. This will be our last one. Over cosine theta squared. All right. Select rule. I think we used our quotient rules here. This line is incorrect. I know why it was incorrect. Okay. Because we're doing two things at the same time. This still has to be tangent of theta. So that we can say that this is a reciprocal rule because so cos. Okay. So now 1 over cosine theta minus parentheses with this thing, we need a sine theta over cosine theta. Okay. And the rule we used was a quotient rule. All right, see, that's they only want you to do one step at a time. So as soon as you've mixed and matched like quotient versus reciprocal, why? But that's where they're going to mark you wrong. Okay, so this is going to be 1 minus sine theta. Okay, oh, we need a fraction. Okay, cosine theta. And we need parentheses. Nope. See if we can put a parentheses in here. Parentheses, and squared. So what did we do? We did an algebra step because we added two fractions together. Okay. And then what we're going to do is we're going to write this, and we're going to say this is a 1 minus sine theta over a cosine, cosine squared theta, and we're going to call that an algebra step. All right, see how we're getting there. So this is a fraction. We have a 1 minus sine theta squared over 1 minus sine squared theta. And we're going to call that a Pythagorean step. All right. And then we're going to have a 1 minus sine theta squared on the bottom. Oops, fraction. And we're going to have factoring. Right? We have 1 minus the sine theta. Yep. 1 plus sine theta. Okay, well, that's an algebra step. Hooray. And now we're going to say this is a 1, oh, we need a fraction. 1 minus sine theta divided by 1 plus sine theta. All right, now I get a sense of what the rules are. Please select a rule. That was an algebra step because we canceled. Okay, and hooray, that's how we do. Okay. Check. Great. Move on with our lives, and there we go. Okay, so they're awful. Okay, but if this is, you know, and it's hard because you can't combine steps, so it's going to be a longer proof than you would have thought. But on second thought, I'm going to say, you know, I'm falling back in love with it because it's a good technique to only do one thing at a time, okay, rather than a whole bunch of things at a time. So as frustrating as it was to kind of learn, like, take one step, justify it, take another step, justify it, and not do like 2 steps with 2 justifications at a time. Like, you know, it's growing on me again. So again, this would be a problem where I really wouldn't say that which side do you start on. Like, either one is going to be just fine, but they said you shall start on the left-hand side. Okay, so play with those a bit. Again, there is, you know, you can always go back and look at the trigger treat problems. Okay, these are all okay. The way that they put these in, I think these are all level 1 easy proofs. I think the next ones have the next section in the, yeah, they do. Okay. Yeah, the next section has 5.2, 5.3 in it. And then I will bet that level 3 is a little maniacal. They probably mix and match and do more on these ones. Okay. Oh, half angles. Okay. That's delightful. Okay. Sum and difference formula. Oh, these are going to be great. Okay. So these, even though they don't look like they're easy, you know, by this book's characterization, they're the easy proofs. Okay. All the ones we just did, they're the easy ones. you're welcome to disagree with that assessment, okay? Because they can be a little tricky. All right. So I'm going to leave you guys with that, and I'm going to stop our video here for this. All right. Thank you. Good luck.